my name is Anton. RockChip is getting more and more popular in the computer vision world. Over the year, my RockChip videos have gained a lot of views, and I can see popularity of RockChip in real time. In this video, I want to talk about two problems that I often write about. What has changed over the year, because there was a lot of updates in Rknn-Toolkit, and how to run different YOLOs like Yolov5, Yolov8, YoloX, and so on. Because it's super common problem, and there are a lot of speculation about this topic. This video is up to date as for October 2023, because if there is new update, everything can change. So in this guide, I will be showing how to do this programming stuff on the fly for an empty board to show you the whole process. So not all commands will work from the first typing, and I didn't edit this part, but it's pretty quick, and at the end of this video you will be able to run all YOLO detection networks on your RockChip NPU board. Let's go. Let's start from the system. I use RockChip RK3568. Actually, it's the same board that was in my previous videos. I also tested this approach on one different board, and I think it should work. But based on these chipsets, there are a lot of boards from a dozen manufacturers, and each one of them have its own problems. From what I have seen, the first one problem: sometimes drivers are already be installed. Sometimes all commands should be executed through sudo command. The third problem, super specific for this board, RK-NPU may not be detected on your version of system. For example, for this RockP3A, I found that all recent system images do not see the NPU model at all. I ended up for this video using an image from a year ago. Here is the specific name of this image. So be careful. This guide is not excellent for different boards, and probably you need to adjust some part of this guide specific for your case. Just don't forget to read all the errors and look on all of the mistakes. Okay, here is the logic of your work. It's pretty complicated, but you need just to understand that you need to prepare your network. You need to train this network or take existing one. In this video, I will take existing one. Second, you need to export your network with the repository that RockChip provide to the version that can be exported through RKNN API. You need to export this network on x86 machine, and only after that you should put this network image on your board and run it. So it's like 4 different steps. And here is the schema of this logic. Let's go step by step on this schema. For the first step, I will use SSH connection to this board, and I will use the script from my previous video. Here is the script. And don't forget to modify all the parameters in this script that are different in your specific board and your specific system. Let me explain how you can install your drivers and RKNN API on the RockChip. First of all, you need to check which version of Python do you have on your board. Here is like 3.7. Okay. After this, you can download my script. I will push it in the description. That will install all requirements on the board. Okay. First, you need to use this one from the script and install get. This is the clean yes problem. You need first to do this. So probably some of this command should be put manually. But anyway, there will be a link on the script. The script is pretty important because yes, everything is working. Right. Now, yes, this script is pretty important to, let me explain the details. So we already checked the version of the Python, so you need to update all this versioning. Okay, let me download it. Excellent. I have new file here. Now we need to change it to the Python 3.7. Pretty important part that you, for some of the board, you need to install this with sudo. But specifically for this board with this version of the system, you don't need to do this. But it's one of the places where the problem can occur. Okay. Now we need to install this script. Okay. In case if your system will require installation through the sudo, you will get it if your script in the future will not find NPU drivers. Okay. This wheel is not a supported wheel on this platform. Let me check again. Sometimes you need to push this command twice. Okay. Sometimes you need to push this command twice to make sure that everything is working. Hmm. Correct name. Okay. Ah, because I didn't put this M. Yes, and now everything will work. So check the real name of the file in my script because it can change from version to version. Okay, and now we will check the installation, but be aware that it's like not complete chain check because even RKNN Lite is installed. Sometimes it happens that it didn't have access to your NPU chip. So to check this access, you anyway need to load your network and try to inference it. We will work with this a bit later in this video. In the second step, I will install YOLO8 repo from RockChip and will use this repo to export my model to the format that could be exported with RKNN. To set up your YOLO repo, you need just git clone. This is Yolov8 repository. You need to create new environments. In my case, I use Windows Anaconda, and here is the name of my environment. In this environment, I need to go to the folder of YOLO8 repo and install the requirements here. In my case, all the requirements are already satisfied because I already set up everything. And next to run your export, you need to take the original, you need to take your YOLO8 model, but I will take the original, this one. You need to put it into your repository. So let me put downloaded model here. After that, you need to run original YOLO approach. Okay, this original YOLO approach to export, but you run this in this specific repository from RockChip. Yes, here is the loading model. If your model have a different name, you should change it, of course. And of course, let export the model with format RKNN. Export complete, result saved. So, and here I can see my new model. Here it is. Okay. On the next step, I will set up RKNN API on my x86 machine and we'll use it to export the model in the RKNN format. The next step, you need to set up environment to export the model on your PC. And it's a bit tricky part because in original Rknn-Toolkit repo, you can find all packages that are available. And as you can see, it's only Python 3.10, Python 3.8, and Python 3.6. Also, there are a lot of possibilities of different conflicts. For example, it should run with specific GCC version. In my case, I just use Ubuntu for Windows 20 and everything is worked successfully. But it may not work in every case. If you are working in Ubuntu, you need to create specific Python environment that will be comparable with these versions. So in my case, I install version 3.8 and it's work successfully. To check how it's work, you just need some it's enough to use some random example, doesn't matter which one. Let's use, for example, this and check if you can export RKNN API. So, wait a second. Okay, in my case, everything exports successfully, but probably it's the main tricky part to install everything for you. Okay, for the next step, we need to use specific repository that RockChip provide to expert detection models. This one. Let's clone it. Okay, now it's successfully working. So let me check. So now it's successfully installed. Here it is. And here we need to go model folder, CV, object detection, YOLO, model convert, and we will work in this specific folder. In this specific folder, we need to change a few scripts. Let me show this. First of all, it's convert YOLO script. In our case, it will be Python 3. And we will run this specific Python export script with this specific config file. Let's look at this config file. So we need our model that we export just a moment ago, and it's here. Let me take it. Okay. Let's put our model name here. In my case, it's 3568 device. Also, I don't want to quantize my model. So I put false here. But if you are quantizing, you need to put here your calibration data set. You need to specify all parameters here and so on. So I will save this. Also, I save this. And let me take this way directly. Okay, now we need to run the script. We need to run this one. So no quantization. Everything successfully exported. Okay, we are rock. And here is model that will work on the RockChip. And on the last stage, we will take the model, put it on the RockChip, and with some problems, I will run it successfully in the end. Let's go. Okay, our repo is successfully cloned, and we need to modify it a bit to make sure that it's running on the RockChip, and put our exported model here to make sure that it's to make it run. Okay, let's take our exported model, put it right here. Okay, the first modification is super simple. For the first modification, we need to check if it's we need to verify that our RKNN executor model is is inferencing through the RockChip API for the board. And for the board, they are using, let me check, this one inference. And of course, we need to modify it right here. I think that's enough for the first modification. And also we need to modify the second. Interesting. Interesting point. In their code, they for YoloV8 specifically, that will be not a problem if you are running like Yolov5, Yolov7, or YoloX. But specifically for Yolov6 and Yolov8 and PPYolo plus, they are using distribution focal loss right here. And they are using PyTorch for it. I don't know why, but it's a bit it's a bit of a problem. So let's modify it. First of all, the only real torch function they're using, it's like softmax. It's easily to find independent numpy softmax function, and of course we need like to subtract the background, make it's like exponent and normalize it. And of course we can now delete the torch usage. We can delete this, I think. I think the numeration will be the same. This will be the same. The same. Also incorrect vector. And I think that the function reshape, it's the same. Now our softmax function will be a bit different, of course, like we need to put it here. And accuracy metrics will be a bit different as well. It should be like we need to use same range function. Of course, but here it's like reshaping to this, but we need to use, I think, numpy array. Second array, and this and it should be the same, and of course we want to return the numpy. Okay, seems like it, but probably we need to fix this in the future. Okay, now let's go to the to this. We are here, and now we need to run. Here it is. It's translated to the English. This one, but we need to make a lot of modification. First of all, we are using Python 3. Here it is. Here it's a definitely error. Model pass. We need to take our model pass. Also in the official documentation, we need to specify the target, or the system will take the default target, and you need to specify specifically your. I think we don't need to use the device ID. We are using default network, so we can use default data, and we definitely need this to show the results. Let me, did I save everything? Yes. Let's test it. Yes. Wait a second. I think I already delete the torch from here. Okay. Here is incorrect model. It's not our exported model, because our exported model was this one. And it should be like this. Of course, if you okay, let's make this one application. Okay, and everything working now. Here is the image. It just shown me directly through the interface. I don't know how it's working, but okay. And now everything seems pretty legit. So I think it's saving it somewhere. I don't know. Probably we need to specify some some folder for it. I don't know, but definitely it's working. The speed, it's like not. I didn't modify anything. Of course, there are like a lot of adjustment to make it work better, but at this time it's working and it's successfully converted. Okay, and here it's like the final adjustment. We need just to init runtime without any parameters. Okay,